All right, so here's some new stuff, okay? So we're now going to look at a little bit of new stuff. This is, again, you can use your little skeleton note structure that I gave you to fill in if you'd like. We're going to talk about cyclic hydrocarbons. Cyclic hydrocarbon. And obviously, cyclic hydrocarbons, I was actually on my way to grab that from you if you wanted me to. You all set with it? Well, I don't want it on your head, so. Okay, so cyclic hydrocarbons, as it says, deal with rings, a cycle, all right? So it's pretty simple. The simplest cyclic ring is one that has 3 carbons. Okay, notice how they've connected and made a ring. Obviously, that means that we have fewer hydrogens. You remember that little formula for when you had alkanes? If you had alkanes, you could figure out how many hydrogens by multiplying how many carbons and then adding 2 more. You can't do that here because obviously we have a carbon that's being bonded to another carbon in a ring. So notice this one is C3H6. All right. So there's your cyclic hydrocarbon. Notice how many hydrogens. To name this thing, we just simply call it cyclo, and then however many there are in the branch. So propane, cyclopropane. Prop is 3. There are 3 carbons, and so cyclo talks about the fact that it's a ringed up cyclic hydrocarbon, and then the prop tells us 3, and then ane because it's all single bonds. So cyclopropane. Okay. Let's look at another example. And I'll put a few more here. Okay? C, 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 C. There you go. What do you think? Any guesses as to the name of this cyclic hydrocarbon? Cyclohexane. It's a cyclic one, so it's cyclo. Hex because there are 6, and then ane because it's all single bonded. Now, as a way of making it simpler or more simple to draw these, you don't need to draw the carbons. So we can draw this as this right here, okay, where all the points would simply be carbons. Okay, so that last one I did, this nice little triangle, all the points are carbons. Same thing here. This cyclohexane, we can draw it like this. So we're going to start to see a lot more of these organic molecules again with these cyclic rings. Okay, cyclohexane. Now I'm going to keep cyclohexane and I'm going to put some branches off of it. So let me kind of clean this up. I'll draw my cyclic hydrocarbon. Okay, and now you can have branches. So 1, there's 2, and how about a branch here? Whatever, they're all different. Just as you would when you name alkanes and alkenes, whatever, you want to go through the lowered, you want to number the carbons in the branch, in the ring, so that the branches are off the lowered numbered carbons. Here's how I would number this one. I would number it 1, 2, 3, 4, 5, 6. And the reason I'm doing that is because I want my branches off of the lowered numbered carbons. This is a 1-methyl. This is 2-ethyl off of the second one. And this is, of course, 4-propyl. Notice that if I numbered a different way, like if I started numbering right here, 1, 2, 3, 4, this would be off the 1, the 3, and the 4. Notice that 1, 2, and 4 are lowered numbers. Okay, so we want to branch them and number them so that they're off of the lowered numbered carbons. So there you are, and you're simply just going to alphabetical list them. Ethyl comes first, so 2-ethyl, 1-methyl, 4-propyl, cyclohexane. That's it. So notice it's the same thing for your branches. And we just add the fact that it's a cyclic hydrocarbon. Okay? Simple enough? The last thing I want to talk about with cyclic hydrocarbons is that we can have multiple bonds. Okay? We can have double bonds between carbons. So let's have this cyclic hydrocarbon, let's say here like this, and we have a second bond there. Okay, and you saw some of these when you were drawing those structures for your shampoo, your sunscreen. But we have a branch there. Let's say we have a double bond. So this just represents a double bond. Okay, and you can have branches. Let me just throw off a branch here, and I'll put one here as well. Again, you're going to want to number them so that you go through the double bond first, just like you do in alkenes. Go through the double bond first, and also number it, because you can go in a ring, you can go in either direction, right? You can spin to clockwise or counterclockwise. You want to number it so it goes through the double bond first, and the branches are off the load number. So I would go 1, 2, 3, 4, and 5. These are ethyls. This is a methyl. Alphabetical, ethyls come first. 1, 2, diethyl, 3, methyl. 1 tells me that's where the double bond is, and cyclopentene. Okay, so the ene tells me it's a double bond, and the 1 tells me where that double bond is. It's after the 1 carbon. Feeling me on that? Brilliant. Yeah, of course.